Mastering unsupervised learning. Unsupervised learning holds the power to unlock hidden patterns in data, threatening to upend traditional notions of machine learning. Why do researchers and data scientists need to understand the concept of unsupervised learning, which involves training models on unlabeled data to identify patterns and relationships, and how does it fundamentally differ from supervised learning, which relies on labeled data to make predictions, and reinforcement learning, which uses feedback and rewards to drive decision-making? The Forest of Patterns. As I wandered through the forest of patterns, I stumbled upon a hidden glade. In the center stood an ancient tree, its branches twisted and gnarled with age. Carved into the trunk was a single phrase: "The unknown is not unknowable." I felt a shiver run down my spine as I realized that this was the essence of unsupervised learning. As I sat beneath the tree, pondering the mysteries of the forest, I began to see the world in a different light. The trees, once individual entities, now seemed connected, their limbs intertwining in a complex dance. The rustling of leaves, the chirping of birds, and the soft rustle of small creatures scurrying through the underbrush all blended together in a harmonious symphony. In this moment, I grasped the fundamental difference between unsupervised learning and its supervised and reinforcement learning counterparts. Supervised learning is like following a well-trodden path, where each step is guided by the wisdom of those who have come before. Reinforcement learning, on the other hand, is like navigating an obstacle course, where rewards and penalties shape our choices. But unsupervised learning is like venturing into the unknown, where the path fades into the wilderness. We must rely on our own curiosity, our own intuition, and our own ability to recognize patterns and relationships. The tree's carving echoed in my mind: "The unknown is not unknowable." As I sat there, the forest began to whisper secrets in my ear. I realized that unsupervised learning is not just a technique, but a state of mind. It's the willingness to embrace uncertainty, to venture into the uncharted territories of data, and to trust that the patterns and relationships will reveal themselves. I recalled a conversation with a fellow researcher who was struggling to find meaning in a dataset. She was searching for a specific answer, a specific pattern, but it eluded her. I suggested that she let go of her preconceptions, that she allow herself to wander through the data without a predetermined destination. And then, something remarkable happened. She began to see connections, relationships, and patterns that had been hidden in plain sight. The tree's branches seemed to nod in agreement as I thought back to my own experiences. There was the time I spent hours poring over a dataset, searching for a specific correlation. But it wasn't until I stepped back, took a deep breath, and let my mind wander that I stumbled upon a hidden pattern. It was as if the data had been waiting for me to let go, to trust that the patterns would emerge. As I rose to leave the forest, I felt a sense of gratitude for the ancient tree's wisdom. The unknown is not unknowable. Unsupervised learning is not just a technique, but a mindset, a willingness to embrace uncertainty and trust in the power of patterns and relationships. In practical terms, this means taking the time to explore, to wander through the data, and to allow oneself to be surprised. It means letting go of preconceptions and embracing the unknown. And it means trusting that the patterns and relationships will emerge, if we only give them the space to do so. As I walked away from the forest, I felt a sense of excitement, knowing that the next time I sat in front of a dataset, I would approach it with a sense of wonder, a sense of curiosity, and a trust that the unknown would reveal its secrets. Unsupervised learning is a type of machine learning paradigm where the model is trained on unlabeled data to identify patterns and relationships. This is in contrast to supervised learning, where the model is trained on labeled data to make predictions, and reinforcement learning, where the model uses feedback and rewards to drive decision-making. Understanding the concept of unsupervised learning is crucial for researchers and data scientists, due to its unique characteristics, advantages, and applications. In supervised learning, the model is trained on labeled data, where each example is accompanied by a target or response variable. The goal is to learn a mapping between input features and the target variable, so the model can make predictions on new, unseen data. In contrast, unsupervised learning does not have labeled data, and the model must identify patterns, relationships, or structure in the data without prior knowledge of the expected output. The fundamental difference between unsupervised and supervised learning lies in the lack of labeled data in unsupervised learning. Without labels, the model cannot be trained to predict a specific output, and instead, it must discover hidden patterns or relationships in the data. This shift in focus from prediction to pattern discovery is what makes unsupervised learning unique. Unsupervised learning has several advantages over supervised learning. Firstly, it can handle large datasets with high dimensionality, where labeling every example would be impractical or expensive. Secondly, unsupervised learning can identify complex patterns or relationships that may not be apparent through labeled data. Finally, it can be used for anomaly detection, customer segmentation, or data visualization, among other applications. Reinforcement learning is another type of machine learning paradigm that differs significantly from unsupervised learning. In reinforcement learning, the model interacts with an environment and receives feedback in the form of rewards or penalties for its actions. The goal is to learn a policy that maximizes the cumulative reward over time. In contrast, unsupervised learning does not involve an environment or explicit feedback, and the model is solely focused on identifying patterns or relationships in the data. Unsupervised learning has numerous applications in various fields. For instance, clustering algorithms can be used for customer segmentation, where customers with similar characteristics are grouped together. Dimensionality reduction techniques, such as principal component analysis, PCA, can be used to visualize high-dimensional data. Anomaly detection algorithms can identify unusual patterns in data that may indicate fraudulent activity or system failures. In addition, unsupervised learning is used in recommendation systems, where users with similar preferences are identified and personalized recommendations are made. It is also used in bioinformatics to identify patterns in gene expression data, or in computer vision to identify objects in images. In conclusion, understanding the concept of unsupervised learning is crucial for researchers and data scientists due to its unique characteristics, advantages, and applications. By identifying patterns and relationships in unlabeled data, unsupervised learning can uncover hidden insights, identify complex relationships, and drive decision-making in various fields.